Hello my dear students, welcome to this next video. In this video we are going to discuss about a problem which was asked in GATE 2020. It is question number 46. It is related to complex analysis. So let us read the statement first and let us see what is being asked. So it says that if gamma is equal to this 1 by 2 e raised to power 3 pi I t and integration of this integral 1 upon z square e raised to power z minus 1 along this gamma is equal to beta pi iota, then what is the value of beta? Okay, so here we are going to use Cauchy residue theorem. What is Cauchy residue theorem? It says that suppose C is a simple closed contour contained in the interior of simply connected domain D. If F is analytical everywhere on and inside C except possibly at the finite number of isolated singularities, let us call them as Z1, Z2, Zn, inside C, then the integral of Fz along C is equal to 2 pi iota times sum of residues. So what is the meaning? Meaning says that if you have a simple curve, right, and you have a function f of z which is analytical everywhere except at some poles, isolated singularities, then the integral of f of z along this curve C would be equal to 2 pi iota times sum of residues. So what are residues? We are going to look at it. Now, but if you look at our curve here, this is gamma, right? So this is not a simple curve. If you look at gamma is equal to 1 by 2 e raised to power 3 pi iota t, and t starts from 0 to 2. So you see, if you start from t equal to 0 to t equal to 2 by 3, at t equal to 0 it is half, and at t is equal to 2 by 3 again this is 2 pi, right, 2 pi iota. If you look at this e raised to power 3 pi iota t, so at t is equal to 2 by 3, this is e raised to power 2 pi iota, right? Okay, so which is the point this. At t equal to 0 also you have this point half, at t is equal to 2 by 3 also you are reaching here. So you are starting here, you are reaching here at t is equal to 2 by 3. And then from 2 by 3 to 4 by 3 you cover another circle. And then from 4 by 3 to 6 by 3 which is 2 you cover the third circle. So that means this particular gamma is this circle which is inscribed 3 times, right? So it means that what I can do is I can write this integral as 3 times the integral over c, where c is this circle, right? Okay, this circle with radius equal to half. Fine. So now, so this will be 3 times 2 pi iota. Here I am applying Cauchy residue theorem, sum of the residues inside that circle. So now what is residue? For residue you calculate the coefficient of 1 by z in your function's expansion, Lorentz series expansion. So if you look at your function here, this is 1 by z square e raised to power z minus 1. So what I am doing is I am writing the expansion of e raised to power z, which is 1 plus z square by 2 factorial, z cube by 3 factorial and so on, minus 1. So this 1 and 1 cancels. So and z also I am taking it out. So this becomes z cube, and on the top I have 1 plus uh, z by 2 factorial, z square by 3 factorial. I am taking the inverse. Now here I am going to use binomial theorem, right? So for binomial theorem I am going to use, so that will be 1 minus, so you are using 1 plus x raised to power minus 1, that is 1 minus x plus x square by 2 factorial and so on. So that is 1 minus x plus x square by 2 and so on, right? Not 2, there is no 2 factorial. Okay, fine. So now this is 1 by z cube. So this is because my aim is to look at the coefficient of 1 by z. So that is what I am trying to do. So here also I know the first term is going to help me, because this will be no, there is no term here which is going to give me 1 by z. Only here I will get 1 by z when I have this and this, right? So this will be minus 1 by 3 factorial, and from here also if you look at this term, uh, second term, right, z square by 3 factorial whole square, so that is going to give me uh, that will give me, just a minute, we are looking for the coefficient of 1 by z square, right? So that will be, yeah, so this will be 3 factorial, this is 3 factorial, not 2 factorial. So this will be 3 factorial square, right? So that will be minus 1 by 6 plus 1 by 9, right? I am sorry, this is a mistake here. Okay, so this will be 1 by 3 factorial square. Okay, so that will be, what is 3 factorial? 3 factorial is 6, right? 3 factorial is 6, so square would be 36, so this will be 1 by 36. So that would be, let us just calculate. So that would be your 36, and then you have minus 6 plus 1, so that would be minus 5 by 36, right? So this is our residual. We will just put it here by 36, and this will be, you can just do the calculations, right? So this is equal to minus 5 by 6 pi iota, and this is equal to, given equal to beta pi iota. Now if you compare, you will get beta equal to, this is wrong, beta equal to minus 5 by 6, right? So you see, this is a simple application of Cauchy residue theorem. So you have to look at what is Cauchy residue theorem, and accordingly you can do it. If you have any doubts, please write in the comment box. Please share this video and subscribe to this channel. Happy learning!